Hi class. In this video we're going to do another variation of parameters problem, but in this case we're going to see how it works with second order equations. So this one is number 11. It's y double prime minus 4y prime plus 4y equals e to the 3x. Now, just as in the first order case, we want to start with the auxiliary equation and the homogeneous solution. So here we have m squared minus 4m plus 4 equals 0, which is actually a perfect square. It's m minus 2 quantity squared equals 0. So this tells us that we have a repeated root of 2. So our homogeneous solution should be C1 e to the 2x plus C2 x e to the 2x. Now, there's a little bit of a difference here when we're doing second order, is that we need to calculate the Wronskian. So to do that, we just pick y1 and y2. It doesn't matter which one you pick at the start, you just have to stay consistent. I'm going to pick them as the order I wrote them. Y1 prime is 2 e to the 2x. Y2 prime is, let's see, I have to do the product rule. That's 2x e to the 2x plus e to the 2x. So the Wronskian is going to be e to the 4x times 2x plus 1 minus e to the 4x times 2x, which is e to the 4x. Okay. Well, now what we need to do is to use our variation of parameters technique. We have the particular solution looks like u1 y1 plus u2 y2, where u1 prime is negative y2g over aw, where a is again the coefficient of the highest derivative appearing, so in our case a is going to be 1. W is the Wronskian. G is the part across the equal sign that's making it non-homogeneous, and y2 is what we decided y2 was over here. So we get, in this case, negative x e to the 2x, g is e to the 3x, over a, which is 1, times w, which is e to the 4x. And I can simplify this to just negative x e to the x. That tells me that u1 is the integral of negative x e to the x dx. This is an integration by parts, where I choose dv to be the most complicated function that I know how to integrate. In this case, it'll be e to the x. U times v is x e to the x minus integral of v du will just be e to the x dx. And now this integral on the inside isn't terribly complicated. And just like in the first order case, while u1 depends on c, any c will work, so I'm just going to set it equal to 0 at the end of the day. u2 prime is y1g over aw. And filling this in yields e to the 2x times e to the 3x over 1 times e to the 4x. Simplifying this just yields e to the x. So u2 is the integral of e to the x dx, which is just e to the x plus c, and maybe if you want c tilde, c prime, whatever. Again, it's going to be set equal to 0 as well, so it doesn't much matter. yp is then u1, so negative x e to the x plus e to the x, times y1, which is e to the 2x, plus u2, which is e to the x, times y2, which is x, e to the 2x. Now if I want, I could simplify this, but you don't have to. I'm actually just going to leave it just like this. I'm going to mark where the particular solution is, and where the homogeneous solution is, and then the general solution is just given by the particular solution plus the homogeneous solution, just like before.